In kindergarten, when you learned how to count on your fingers, you were using the counting numbers. The counting numbers start with 1 and continue to infinity. Whole numbers are the counting numbers with 0 added in. The integers take the whole numbers and all of their opposites. So we have 0 and 1 and 2 and 3 all the way up to infinity. But then we also have the opposite of 1 and the opposite of 2 all the way down to negative infinity. The rational numbers are all the numbers in between the integers that can be written as a fraction. Numbers that can be written as the ratio of two integers. Examples would be 3/4, negative 1/3, and 5, because 5 can be written as a ratio 5/1. Another way to define a rational number is a number whose decimal either ends, it terminates, or repeats. If we look at 3/4, 3/4 as a decimal is 0.75. That decimal terminates, it ends. If we look at negative 1/3, negative 1/3 as a decimal is negative 0.3, repeating. So even though this decimal doesn't terminate, it doesn't end, it does repeat. Irrational numbers are the real numbers that are not rational. It's all the numbers that we can't write as a fraction of two integers, and it's all the numbers whose decimals don't terminate and don't repeat. Examples would be the square root of 2 and pi. If we look at the square root of 2 and we try to write it as a fraction, we're going to have the square root of 2 over 1. Well, the square root of 2 is not an integer, so we can't write it as a fraction of two integers. If we look at the decimal of the square root of 2, the square root of 2 is 1.414213562. Our calculator actually cuts off the number. This decimal keeps going on for infinity with no repeats, and it never ends. So we can approximate irrational numbers as about 1.414. But this is not exactly the square root of 2. The square root of 2 is the square root of 2 big. If we look at pi, pi is approximately 3.141592654. This decimal also keeps going on, and it never repeats and it never terminates. We can abbreviate pi as about 3.141, but this is not the exact answer. Pi is pi big. If we want to graph these numbers on a number line, we first need to start with a number line. Now I'm going to put 0 right in the middle, and then 1, 2, 3, 4, 5, and then negative 1, negative 2, to negative 5. This number line is all my real numbers. All of these are my real numbers. We'll study imaginary numbers later. For now, we're working with real numbers. So to put 2.7 on my number line, it's between 2 and 3, a little more than halfway. So this point is 2.7. If we want to put negative 4/3 on my number line, negative 4/3 is negative 1.3 repeating. So I'm going to go negative 1 and then another third. So this point right here is negative 4/3. And then the square root of 2 is approximately 1.414. So it's about 1.4, a little less than 1.5. Notice that all of these numbers do fit somewhere on the number line. If I had to write them in increasing order, my smallest number is negative 4/3, followed by the square root of 2, followed by 2.7. The properties of addition and multiplication. Closure. If I add two numbers that are real numbers, my answer will be a real number. I'm not going to get some weird answer. If I add two numbers, my answer will be a number. If I multiply two numbers, my answer will be a real number. This property isn't hugely important right now, but it will be later on. The commutative property says if I add two numbers, I can switch the order in which I add and still get equivalent answers. Same with multiplication. If I multiply two numbers together, I can switch the order and still get equivalent answers. The associative property says if I have all multiplication in a problem, it doesn't matter what order I do that multiplication, I will get equivalent answers. Same with multiplication. If I have all multiplication in a problem, I can associate the numbers differently. I can do the multiplication in a different order and get the same answer. The identity property says this. I'm going to start with an integer. I'm going to add something, and for an answer, I want to get that integer back. Well, in the addition world, the additive identity is 0. A plus 0 is A. In the multiplication world, I'm going to start with A and multiply by something to get A for an answer. In the multiplication world, the multiplicative identity is 1. The inverse property. I'm going to start with A again. I'm going to add something, but for an answer, I want to get my identity 0. Well, in this case, A plus the opposite of A is 0. Notice I said opposite and not negative, because if A was negative to begin with, the opposite of a negative number is a positive number, and the opposite of a positive number is negative. So this symbol really means opposite. So the opposite is the additive inverse. In the multiplication world, I'm going to start with A, multiply by something, and get 1 for an answer. What do I need to multiply A by to get 1 for an answer? 1 over A. 1 over A is the reciprocal. Reciprocal is the multiplicative inverse. And now the distributive property. The distributive property is a combination of both addition and multiplication. It says this. If I'm going to group two numbers together and multiply those two numbers by another number, I can do that in a different order and still get the same answer. I can take A times B and add it to A times C. And whether that A is on the left of my parentheses or on the right of my parentheses, I can still distribute. Now the operations. Addition. The words that mean addition are sum and total. For subtraction, we have difference and minus. For multiplication, we have product and times. For division, we have quotient and divided by. Now these aren't the only words that mean these things. These are just some examples. So if we want to find the difference between 7 and negative 10, our operation is subtraction, and we're going to subtract 7 minus negative 10. Now to subtract a negative number, subtracting a negative number is the same as adding its opposite. The opposite of negative 10 is positive 10. The opposite of subtraction is addition. So it's really 7 plus positive 10, which is 17. If you think of this on a number line, we have positive 7 and negative 10. So what's the difference between positive 7 and negative 10? Well, the difference between these two is 17. If I want to find the quotient of negative 24 and 1/3, quotient tells me to use division. And I'm going to have negative 24 divided by 1/3. Well, how do I do division by a fraction? Well, dividing by 1/3 is the same as multiplying by the reciprocal. And the reciprocal of 1/3 is 3. And I'm going to take negative 24 and multiply by 3. Kind of like subtracting was the same as adding the opposite, division is kind of like multiplying by the reciprocal. And negative 24 times 3, a negative times a positive is a negative, and 24 times 3 is 72. If you think of it this way, if I have 24 things, and I divide each thing in 1/3, each one of those things is now 3. So I really have 3 times 24. So 24 divided by 1/3 is actually getting bigger to 72. I just need to worry about my subtraction sign here, my opposite sign, and make sure that my answer is also negative.